This video is for problem 70 of section 8.6. A student sits on a rotating stool holding two 3-kilogram objects. When his arms are extended horizontally, the objects are 1 meter from the axis of rotation, and he rotates with an angular speed of 0.75 radians per second. The moment of inertia of the student plus the stool is 3 kilogram meters squared and is assumed to be constant. The student then pulls in the objects horizontally to 0.3 meters from the rotational axis. Part A asks us to find the new angular speed of the student. So we'll do this using the conservation of angular momentum. Angular momentum is equal to the moment of inertia times the angular velocity So let's write down the variables that we know. We know the masses are both equal to 3 kilograms. We know the initial radius of his arms is 1 meter. We know the moment of inertia of the student plus the stool is equal to 3 kilogram meters squared. We know the initial angular velocity is equal to 0.75 radians per second. We know his final radius after he brings his arms in is equal to 0.3 meters. When he brings his arms in, he's going to change his angular velocity. And that is what we are looking for. So we can find the final angular velocity using this equation to the left, and we must first determine the initial moment of inertia and the final moment of inertia. In both cases, the moment of inertia will be equal to the inertia of the masses plus the moment of inertia of the student and stool. For the moment of inertia of the masses, we use the equation mr squared, and because there are two of them, we'll just say 2mr squared. So the initial moment of inertia will be 2 times the mass times the initial radius squared plus the moment of inertia of the student plus the stool. And the final moment of inertia will be 2 times the mass times the final radius squared plus the moment of inertia of the student and the stool. So let's go back into our original equation. On the left over here, I'm just going to divide by the final moment of inertia, so our equation solves for the final angular velocity. And now we can put in the numbers that we know. So 2 times the mass of 3 kilograms times the initial radius before he moves his arm in of 1 meter, plus it tells us the moment of inertia of the student plus the stool is always equal to 3 kilogram meters squared. And this is divided by the final moment of inertia, 2 times 3 kilograms times the final radius squared, so 0.3 meters squared plus 3 kilogram meters squared, all times the initial angular velocity of 0.75 radians per second. And when you put this in your calculator, you will get 1.9 radians per second is equal to the final angular velocity. So notice how when he pulled his arms in, he started to rotate faster. So that's part A. Part B asks us to find the kinetic energy of the student before and after the objects are pulled in. So he's rotating, not moving linearly, so we need the initial rotational kinetic energy and the final rotational kinetic energy. And let's recall that our rotational kinetic energy equation is 1/2 the moment of inertia times the angular velocity squared. So the initial rotational kinetic energy is equal to the initial moment of inertia times the initial angular velocity squared. And this term is our initial moment of inertia excuse me, I lost the 1/2. And when you put this in your calculator, you will get 2.53 joules. And then we do the same for the final rotational kinetic energy. And this will give you 6.39 joules.